Imagine for a second that you are standing on a giant rock.
Okay.
No, really, close your eyes and really picture it. You're on this rock, and it isn't just sitting still. It's spinning.
And spinning pretty fast is right.
It's not a gentle, lazy spin. It's rotating at roughly 1,000 miles per hour if you're at the equator.
Wow.
But that's not all. This spinning rock is also hurling through the freezing vacuum of space, circling a massive ball of burning gas. A nuclear furnace that's 150 million kilometers away.
It sounds like the opening scene of a high-stakes sci-fi disaster movie when you frame it like that. It's pretty intense.
It does, doesn't it? But that is our reality. That's the stage we are standing on right now. It sounds terrifying, but it's also incredibly precise. It's the clockwork of the cosmos.
It really puts things into perspective. I mean, we get so caught up in our daily commute, the traffic, our coffee orders, the stress of the exam cycle.
Oh, yeah.
That we forget we are essentially astronauts on a spaceship called Earth. We're crew members on a vessel traveling through the void.
Exactly. And today, we are going to stop taking that spaceship for granted. We're decoding the address of humanity. We're doing a deep dive into the very neighborhood we live in, the Earth in the solar system.
And I think it's important to set the context here. We aren't just stargazing for the sake of poetry, though it is poetic. We are analyzing this through a very specific lens.
All right. I want to be clear right off the bat. This is a special session. This coverage is specifically tailored for the Simplified UPSC by PPP YouTube channel. We are taking the foundational material, specifically NCERT Class 6, Geography Chapter 1, and we are deconstructing it for the UPSC aspirant.
Which is a critical distinction. I mean, a sixth grader reads this chapter to learn the names of the planets and maybe make a papier-mâché model.
I remember doing that. Mine was mostly glue.
Right. But an aspirant needs to read this chapter to understand the fundamental physics of the universe, the geometry of the Earth, and how those factors drive everything from climate zones to satellite communications.
So before we blast off into the stratosphere, I do have a humble request for you. If you are listening to this and you find value in what we are doing, if this helps you visualize your prep better and makes the concept stick, please subscribe to the Simplified UPSC by PPP channel.
It really is the best way to keep this super useful content coming your way.
It is. And if you're capable, your support on Patreon is absolutely vital for the continuation of these deep dives. High-quality research and production, well, it takes time and resources.
We really can't do this without you. We mean that.
We also have to give a heartfelt shout-out to all our current supporters. You guys are the fuel in our rocket. You're the reason we can sit here and unpack these topics week after week.
Absolutely. Also, don't be a passive listener. Engage with us. Like the content, share your valuable comments. We do read them, and they help us improve. We want this to be a two-way conversation.
Now, here's a massive resource alert for you. We know you need notes. You need practice questions. You can't just listen and hope it sticks by osmosis. So we made free notes with practiced previous year questions BYQs available on the public Telegram channel.
But for those of you who want to streamline your preparation, and let's be honest, time is the most valuable currency in the UPSC journey, there is a premium access option.
Tell them about it.
If you want to access all the videos of this series at once, along with the corresponding premium notes, and when we say premium, we mean detailed notes, extra PYQs, and model mains answers organized perfectly, you should join the private Telegram library.
And it's simple to join. Just DM us on the public Telegram channel to get access to that private library. It's the upgrade your prep needs. Okay, business aside, let's get to the mission.
The mission today is deceptively simple. We're tackling the Earth and the solar system. Now, I can hear some of you thinking, Class 6 science. Seriously, I learned this when I was 11.
I'll admit, I definitely thought that when I saw the reading list. I thought, great, an easy week.
It's a common trap, a very common trap. But here's the thing. This is the foundational bedrock. You cannot answer high-level UPSC geography questions about planetary physics, location, time zones, or even the geopolitical implications of space exploration if you don't master these basics first.
If your foundation is cracked,
The building falls down. Simple as that.
So let's start looking up. We're standing on the Earth looking at the night sky. We see the moon, we see the sun during the day, and we see thousands of tiny dots of light. What is the collective noun for all of this stuff?
The broad term is celestial bodies. That encompasses everything shining in the night sky, the sun, the moon, the planets, the asteroids, all of it. If it's natural and it's up there in space, it's a celestial body.
Okay, that's the big umbrella term.
Exactly. But within that massive group, there are crucial distinctions that matter for physics and for the exam.
Right, and the big one, the one that really defines how the universe works, is the difference between a star and, well, everything else. What actually defines a star?
It comes down to composition and energy. So some celestial bodies are just massive. They are incredibly hot and made up of gases.
Yeah.
But the defining characteristic, the thing that makes a star, is that they have their own heat and light, which they emit in large amounts. They are engines. They're nuclear reactors floating in space, constantly fusing elements and releasing enormous amounts of energy.
So the sun
Is a star. It's a medium-sized star, actually. It's just the one that happens to be close enough to keep us warm. It's our local star.
It's funny because when you look at the night sky, those other stars look like tiny little diamonds, pinpricks of light. But the sun looks like a giant basketball. Why is the visual difference so extreme if they're essentially the same type of object?
It is purely a matter of perspective and distance. Think about an airplane.
Okay.
When you are standing next to it on the runway, it's huge. It towers over you. You can't even touch the top of the wheels. But when you see that same plane flying at 30,000 feet, it looks like a toy. You could pinch it between your fingers.
So the stars are the airplanes at 30,000 feet.
Exactly. The stars in the night sky are similar to the sun. Some are significantly bigger and hotter, actually, but we don't feel their heat or see their true size because they are very, very far from us.
And when you say far?
We are talking light years away. If the sun were a headlight on a car 10 feet away from you, the next nearest star would be a headlight in a different country. That's the kind of scale we're dealing with.
That's hard to even comprehend. And that distance brings us to the patterns these stars make. Humans are pattern-seeking animals. We look at chaos and try to find order. I remember looking up as a kid and trying to find, shapes.
And those are constellations. They are patterns formed by different groups of stars. It's essentially a celestial connect-the-dots game that people have been playing for thousands of years. One of the most famous ones is Ursa Major.
Also known as the Big Bear.
Correct. But within that large constellation, there's a specific subgroup that is very significant, especially in Indian culture and history.
The Saptarishi.
Yes. And let's break down the Sanskrit for a moment because it's helpful. Sapta means 7. Rishi means sages.
The 7 sages.
It's a group of 7 bright stars that forms a part of the Ursa Major constellation. If you look at it, it looks a bit like a ladle or maybe a big question mark hanging in the sky.
And this wasn't just for looking at pretty shapes or telling stories around a campfire about sages. This was functional technology for ancient people.
Absolutely. This is a key point for history and culture as well. Before GPS, before magnetic compasses were widespread, people used stars to navigate. Specifically, they used the North Star or the Pole Star.
Why that one specifically? Why not any bright star? Why not follow Sirius or Betelgeuse? They're super bright.
Because the Earth spins.
Yeah.
If you pick a random star, it will appear to move across the sky throughout the night as the Earth rotates. It rises in the east and sets in the west, just like the sun.
So if you follow a moving target, you end up walking in circles.
You end up walking in circles. But the pole star is unique because it sits almost directly above the Earth's north pole. It's aligned with our axis of rotation. So as the Earth spins, the pole star appears to remain stationary. It always indicates the north direction. It's a fixed point.
That is a very clever observation by our ancestors. It's like the pivot point of a spinning top.
Yeah.
But here's the practical problem. The sky is full of stars. If I'm lost at sea or in a desert, how do I know which one is the pole star? It's not like it has a label or, flashes red.
No, it doesn't. So you use the Saptarishi as your guide. You look at the pointer stars. These are the 2 stars at the end of the ladle's bowl, the part opposite the handle.
Okay, I'm visualizing the ladle, the part you dip in the soup.
Right. Take the 2 stars that form the outer edge of that bowl. If you draw an imaginary line connecting those 2 stars and then extend that line further out, about 5 times the distance between the 2 stars, it points directly to a reasonably bright star.
And that's it.
That is the pole star.
That is such a cool practical application. It connects the shapes to actual utility. It's celestial geometry.
It is ancient science at its best.
Okay, let's zoom in a bit from the wider universe and constellations to our specific neighborhood, the solar system.
Let's start with the word itself, solar. Words have power, and in UPSC, etymology can often help you deconstruct terms you might not know in an exam. Solar comes from Roman mythology.
The Romans had a god for everything, didn't they?
Pretty much. And Sol is the sun god. So solar literally means related to the sun. The solar system is the family of the sun.
And the sun is the undisputed head of that family. It's the patriarch.
It is the powerhouse. It sits at the center.
Yeah.
In terms of mass, it comprises over 99% of the mass of the entire solar system.
Wait, say that again. Over 99%.
Over 99%. Think about that. If the solar system were a bucket of sand, the sun would be the bucket and almost all the sand, and all the planets, asteroids, everything else would be a few grains of dust.
That is insane.
It's huge and made of extremely hot gases, mostly hydrogen and helium undergoing fusion.
What is its job description? Why do we keep it around?
Two main roles. First, it provides the pulling force gravity. That massive gravity binds the entire system together, keeping the planets in their orbits rather than letting them fly off into the void. And secondly, it is the ultimate source of heat and light for us. Without it, Earth is just a frozen rock in the dark.
I mentioned in the intro that it's 150 million kilometers away. That number is staggering. It's hard to wrap your head around.
It is. To put it in perspective, light travels at 300,000 kilometers per second.
Which is fast.
Fast enough to go around the Earth 7.5 times in 1 second. Even at that breakneck speed, it takes sunlight about 8 minutes to reach us.
So when we look at the sun, which we shouldn't do directly, obviously, we're seeing it as it was 8 minutes ago.
We are effectively looking into the past, and that distance is crucial. If the sun were much closer, that tremendous heat would destroy us. If it were further, we'd freeze.
We're in just the right spot.
We are at just the right distance to benefit from it without being incinerated. This is often referred to as the Goldilocks zone. Not too hot, not too cold, just right.
Let's talk about the rest of the family then. The planets.
Right. The word planet itself comes from the Greek word planetai, which means wanderers.
Why wanderers?
Because to the ancient observers, the stars stayed fixed relative to each other. The constellations, like Ursa Major, they didn't change shape night after night. But these few specific lights, Mercury, Venus, Mars, Jupiter, Saturn, they moved. They wandered across the background of fixed stars.
So they didn't follow the rules.
They didn't? One week they were in Taurus, the next in Gemini, so they were the wanderers.
And the physical distinction between them and stars.
Unlike stars, planets do not have their own light or heat. They are dark bodies. They merely reflect the light of the stars. If you turned off the sun, the planets would essentially vanish from sight. They are mirrors, not lamps.
And we have 8 of them.
8 planets. In order of their distance from the sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune.
I always struggle to remember the order. I know the NCERT source has a famous mnemonic for this.
They do. It's a classic. My very efficient mother just served us nuts.
Let's break that down.
M for Mercury, V for Venus, E for Earth, M for Mars, J for Jupiter, S for Saturn, U for Uranus, N for Neptune.
My very efficient mother just served us nuts. I like that. Though I feel like nuts is a bit anticlimactic for Neptune. Neptune is this giant, windy, blue ice giant. Nuts feels a bit small.
It works for the memory, though. And for the exam, recall is everything. You don't want to be sitting in the exam hall wondering if Mars comes before or after Earth.
Very true. Now, these planets aren't just floating aimlessly. They have paths.
Correct. They move around the sun in fixed paths called orbits. And it's important to note the shape. These paths are elongated. They aren't perfect circles. They are elliptical.
Let's run through some rapid-fire facts about these neighbors. Let's start with Mercury.
Mercury is the nearest to the sun. Because it has the shortest track to run, it takes only about 88 Earth days to complete one round along its orbit. It's whipping around there fast.
So a year on Mercury is just 88 days.
Exactly. But interestingly, its rotation, its day, is very slow. It's a place of extremes.
Venus.
Venus is fascinating because it is often called Earth's twin. Its size and shape are very similar to that of the Earth.
Don't let the name fool you.
No, it's an evil twin. It has a thick, toxic atmosphere of carbon dioxide, creating a runaway greenhouse effect. It's actually hotter than Mercury, even though it's further from the sun.
That's a key concept for environment and ecology, too. Greenhouse gases trap heat. Venus is the ultimate warning sign of climate change gone wrong.
Precisely. It's a cautionary tale written across an entire planet.
And then there's the one that got demoted, Pluto. I feel like my generation took this personally.
Poor Pluto. A lot of people did. Until August 2006, it was considered the 9th planet. But science evolves. The International Astronomical Union held a meeting and decided that Pluto didn't meet the new, stricter criteria for being a planet.
What was the deal breaker? Why did it get kicked out of the club?
The main thing was that it hadn't cleared its orbit. A real planet, a full-fledged planet, is the gravitational bully of its orbit. It either absorbs or ejects everything else in its path.
Okay.
Pluto was too small to do that. It shares its neighborhood with a lot of other icy debris in what's called the Kuiper Belt. So it was reclassified as a dwarf planet, along with other objects like Ceres and 2003 UB313.
So it's still there, just with a different job title.
Exactly. It's still a very interesting world, just not a planet by the current definition.
What about the big guys? The ones with the bling?
You mean the rings? Yes, Jupiter, Saturn, and Uranus all have rings around them. Saturn's are the most famous and visible, of course, but the others have them too.
What are they made of? From pictures, they look like solid discs, like a hula hoop or something.
They are deceptive. They aren't solid at all. They are belts of small debris, countless particles of ice, rock, and dust. Billions of them.
So it's not one solid ring?
No, it's a collection of tiny moons, basically, all orbiting the planet together in a flat plane. If you flew a spaceship through them, it would be like flying through a cosmic hailstorm.
You can see them from Earth.
With a good telescope, yes, you can definitely see Saturn's rings. It's one of the most beautiful sights in the night sky.
Moving on to the star of the show, or rather, the planet of the show, Earth.
Our habitat. It is the third nearest planet to the sun and the fifth largest planet in size. A nice middle ground in many ways.
Now, here is a point that I know is critical for UPSC aspirants, the shape of the Earth. If you write sphere in a mains answer, you might lose points, right? Or at least you won't impress the examiner.
You likely wouldn't get the credit for technical precision. The Earth is not a perfect sphere because it spins, centrifugal force pushes the middle out, so it's slightly flattened at the poles and bulges at the equator.
So it's a bit chubby around the middle.
Exactly. And the technical term for this specific shape is geoid.
Geoid. That sounds like a vocab word we need to unpack.
It is, and it's a good one to know. Break it down. Ge is the Greek root for Earth.
Okay.
And oid means resembling the shape or form of. So geoid literally means an Earth-like shape. It's a definition that defines itself. The Earth is shaped like the Earth.
That's oddly circular, but it makes sense. The shape is unique to Earth.
It is, and the etymology in the chapter is actually really helpful. Ge is a building block. Ge plus logia gives you geology, the study of Earth. Ge plus matria gives you geometry, the measurement of Earth. Ge plus oid gives you geoid.
That's a great way to remember it. Just break down the roots.
Okay.
So why is this flattened sphere so special? Why are we here and not on Venus or Mars?
Well, as we mentioned, it's in the Goldilocks zone. Earth is a unique planet because it has conditions favorable to support life as we know it. It is neither too hot nor too cold. Crucially, it has liquid water and an atmosphere.
And it's not just any air.
Right. It's not the crushing carbon dioxide of Venus or the thin wisps of Mars. The air contains life-supporting gases like oxygen. And the atmosphere acts as a blanket, protecting us from harmful UV rays and regulating temperature. It's a complete life support system.
And all that water is visible from space.
It really is. From outer space, the Earth appears blue because 2/3 of its surface is covered by water, hence the blue planet. This is unique in our solar system. Liquid water on the surface is the holy grail of habitability. Everywhere else, it's either solid ice or water vapor.
We can't talk about Earth without talking about our best friend, the moon.
Our constant companion. The moon is a satellite, a natural satellite, and its diameter is only about 1/4 that of the Earth.
It looks huge, though. Sometimes, especially when it's near the horizon, it looks as big as the sun.
Again, that's perspective. It's an illusion. It appears big because it is much, much nearer to our planet than other celestial bodies. It is about 384,400 kilometers away.
384,000 versus 150 million for the sun.
Exactly. It's right in our backyard, cosmically speaking.
That is a massive difference.
Yeah.
Now, here is a mystery I've always wondered about. We always see the same face of the man in the moon. We never see the back of his head. We didn't even know what the far side of the moon looked like until we sent probes. Why is that?
This is a fantastic point, and it's due to a phenomenon called synchronous rotation, or tidal locking.
Okay, what does that mean?
The moon moves around the Earth in about 27 days. That's its revolution period. But it takes exactly the same time, 27 days, to complete one spin on its own axis. That's its rotation period.
So the spin and the orbit are locked together. They're in sync.
Perfectly in sync. Because the orbital period and the spin period are identical, the moon turns just enough to keep the same face pointing at Earth at all times.
That is wild. It's like if you walked around a chair while spinning your body at the exact speed to keep your face pointing at the chair the whole time.
That is the perfect analogy. If you didn't spin, eventually your back would face the chair. But because you spin while you walk, you stay locked. The Earth's gravity has locked the moon into this dance over billions of years.
Is there life up there? Could we set up shop?
No, not easily. The moon does not have conditions favorable for life. It has no atmosphere to trap heat or hold breathable air. It swings between extreme heat and extreme cold. And it's covered in mountains, plains, and depressions.
Interestingly, the text mentions that those shadows you see in the full moon, the features that make up the man in the moon, are cast by these topographic features, the mountains and depressions blocking the sunlight.
That's right. It's not just distinct coloration. It's texture that we are seeing from 384,000 kilometers away.
Speaking of being on the moon, we have to mention the history.
Neil Armstrong. He was the first man to step on the surface of the moon on July 20th, 1969. One small step for man, one giant leap for mankind. An iconic moment.
The text also mentions satellites. The moon is a natural satellite, but we've thrown a lot of our own stuff up there too.
A lot, yes. Human-made satellites. These are artificial bodies designed by scientists to gather information about the universe or for communication. They are carried by rockets and placed into orbit around the Earth.
And India is a major player here.
A huge player. The text mentions INSAT, IRS, AGUSAT. These are crucial for India's telecommunications, weather forecasting, remote sensing, and education infrastructure.
AGUSAT, that's the education satellite.
Yes, it was the first satellite in the world dedicated exclusively to the educational sector. A very forward-thinking mission by ISRO.
Okay, we've covered the big stuff, the planets, the moon, the sun.
Yeah.
But space is also full of, well, debris, leftovers from the construction site.
Exactly. The debris of the solar system's formation. First, we have asteroids. These are tiny bodies, relatively speaking, that move around the sun. They aren't planets, they aren't comets, they are essentially flying rocks.
And they have a specific hangout spot, right? A specific neighborhood.
They do. There is a specific belt where most of them congregate, the asteroid belt, located between the orbits of Mars and Jupiter. It acts as a sort of dividing line between the rocky inner planets and the gas giant outer planets.
Where did they come from? Are they just rocks that never formed a planet?
That's the leading theory. Scientists are of the view that asteroids are actually parts of a planet that exploded many years ago, or perhaps material that simply never coalesced into a planet because of Jupiter's massive gravity constantly stirring things up.
That is a violent image, an exploded planet. It hints at how dynamic the history of the solar system is. It wasn't always this neat and tidy.
Not at all. It was a chaotic, messy place.
Yeah.
And then you have meteoroids. These are even smaller pieces of rocks moving around the sun. They can be pieces of asteroids or debris left behind by comets.
These are the shooting stars, right? The things you make a wish on.
Well, the meteoroid is the rock in space. When it enters the Earth's atmosphere, that's when the magic happens. Friction with the air heats it up rapidly. It burns and creates a brilliant flash of light. That flash is the meteor or shooting star.
So the shooting star is the event, not the rock itself.
Correct. And usually they burn up completely, they turn to dust high in the atmosphere, but sometimes a meteoroid is big enough or dense enough that it doesn't burn up completely.
It survives the fiery descent.
Right. If a piece of it actually strikes the Earth's surface, it is then called a meteorite. And it can create a hollow or a crater.
Like the Lonar Lake in Maharashtra. That's a famous example in India.
Exactly. That was formed by a meteorite impact tens of thousands of years ago. It's a geological scar, a reminder that we live in a cosmic shooting gallery.
A comforting thought. Okay, we are zooming out again. We have Earth, the solar system.
Yeah.
What's the next level up on the address?
The galaxy. Specifically for us, it's the Milky Way galaxy. If you are in a very dark place, away from city lights, you might see a faint, whitish, broad band of light arching across the sky.
I've seen pictures, but it's hard to see in most places now.
It is, due to light pollution. But that band is not a cloud. It's a cluster of millions and millions of stars that are so far away they blur together into a milky haze.
I love the ancient Indian name for it.
Ganga.
Ganga, meaning the river Ganges.
Yes. They saw it as a sacred river of light flowing in the sky. It's a beautiful, poetic description of a physical reality.
And what is a galaxy, technically speaking?
A galaxy is a huge system of billions of stars and clouds of dust and gases all bound together by gravity. It's an island universe. And our solar system is just one tiny subdivision in this massive city of stars. We're way out in one of the spiral arms.
And the universe. The final line of the address.
The universe is the totality of everything. It's made up of millions, maybe billions of such galaxies.
That scale is just... it's hard to imagine. It breaks your brain a little.
It is. The text emphasizes this hierarchy. Earth is part of the solar system. The solar system is part of the Milky Way. The Milky Way is one of countless galaxies in the universe. We are just a tiny speck in that hierarchy. It's a very humbling thought.
Okay, that is the insert summary. We've covered the facts, but as you said at the start, this is a simplified UPSC by PPP deep dive. We need to connect this to the exam. How does knowing that the moon is 384,400 kilometers away help me clear UPSC? Or is it just trivia?
It's absolutely not just trivia. It's all about the implications. Like, look at the speed of light again. The insert text mentions that light travels at about 300,000 kilometers per second. It also says sunlight takes about 8 minutes to reach Earth.
Okay, we covered that.
Right. But think about a Science and Tech question paper 3 of general studies. This basic concept explains time delay in space communication. This is latency. If you are communicating with a rover on Mars, or the Aditya L1 mission observing the sun, you cannot have a real-time conversation.
Because of the distance, the signal takes time to travel.
Right. If something goes wrong on a Mars rover and it sends a distress signal, it might take, depending on the planet's positions, anywhere from 10 to 20 minutes for that signal to even reach Earth.
And then another 20 minutes for our command to get back.
Exactly. In that 40-minute round trip, the rover might have already fallen off a cliff, so you have to design missions with a high degree of autonomy. You have to account for that light speed lag. It's a direct application of this basic geography fact.
That makes perfect sense. It governs how we design autonomous systems for space exploration. What about previous year questions? You mentioned there was a linkage to dynamic changes.
Yes. Let's look at the 2013 prelims, specifically question 18 from the source material provided. The question asked, which of the above are responsible for bringing dynamic changes on the surface of the Earth?
And the options were a long list.
Yes, the options included electromagnetic radiation, geothermal energy, gravitational force, plate movements, rotation of the Earth, and revolution of the Earth.
That sounds like a mix of physics and geography. It's pulling from multiple concepts.
It is. Now, Class 6, Chapter 1 focuses on the Earth in the solar system, but it sets the stage. It introduces the Earth as a celestial body in motion. The very next concept, which is hinted at here with orbits and spin, is rotation and revolution.
So how does this chapter help answer that question?
The expert analysis here is that understanding the Earth as a part of the solar system is the prerequisite to understanding why rotation and revolution bring dynamic changes. You can't understand seasons, which are a massive dynamic change, without understanding the revolution of the tilted Earth around the sun.
Which is a model established right here in this chapter.
Exactly. You can't understand day and night or the Coriolis effect that drives wind patterns without understanding the spin, the rotation of the Earth. This chapter provides the mechanical model of the system.
So the solar system chapter provides the mechanics, and the dynamic changes are the result of those mechanics operating over time. It's the why behind the what.
Precisely. It builds the mental model. If you don't know the Earth revolves, you can't explain why the weathering patterns might shift or why insolation, which is incoming solar radiation, varies throughout the year.
Okay, that makes sense. And let's look at a mains question. You flagged the 2025 General Studies Paper 1, Question 16. It asks to discuss how the changes in shape and sizes of continents and ocean basins of the planet take place due to tectonic movements of the crustal masses.
Now, this is a heavy question about plate tectonics. It's a core concept in geography.
Does Class 6 cover tectonics? I don't remember seeing it in the notes.
Not explicitly. It doesn't use the words plate tectonics,
Yeah.
but due to, remember the asteroids?
Exploded planet theory.
Exactly. The text says scientists believe asteroids are parts of a planet that exploded. This introduces a fundamental concept. Celestial bodies are not static, unchanging rocks. They are dynamic. They can explode, they can break apart, they can collide, they can accrete.
So it breaks the idea that the ground beneath our feet is permanent and unmoving.
Correct. This idea of planetary dynamism is the seed. If a whole planet can explode to create asteroids, surely a planet's crust can crack and move to create continents and ocean basins. It frames the Earth as an active geologic system, not a passive block of stone. It's about mindset.
That is a deep connection. It's about understanding the fundamental nature of planetary bodies before you even get to the specifics of tectonics.
Correct. And let's not forget the term geoid. This is a quick win for aspirants and mains.
How so?
If you are writing a mains answer about the shape of the Earth or gravitational anomalies or even how satellite orbits are calculated, using the term geoid instead of round or sphere shows technical precision.
It's a signal to the examiner.
It signals to the examiner that you know your NCERTs inside out and that you understand the nuances. It separates a generalist answer from a specialist answer. It's one of those little things that can add half a mark.
And those half marks add up.
Absolutely. Even the Goldilocks concept, the favorable conditions for life, that connects directly to questions about potential life on exoplanets or the habitability of Mars. Why do we look for water on Mars? Why is ISRO sending missions to the lunar South Pole to find water ice?
Because we know from Earth, from this very chapter, that water is the key ingredient for life as we know it.
Exactly. The logic flows from this foundational chapter. It all connects.
So we've traveled from the vast universe down to the Milky Way galaxy, into our solar system, past the asteroid belt, landed on the geoid Earth, and looked up at our companion, the Moon.
It's quite a journey, and we've seen that the sun is a star, planets are wanderers reflecting light, and the distances involved are just immense.
We've also linked it to the practical side navigation with the pole star, and the exam side implications of rotation, revolution, and planetary composition.
We have. It's the bedrock, like we said.
Before we wrap up, I want to leave the listener with a thought. We talked about the unique planet. The Earth has water, air, oxygen. It's in that perfect Goldilocks zone.
The only place we know of, for sure, where life exists, we haven't found it anywhere else yet.
Exactly. But we also talked about the sheer scale of the universe. Millions of galaxies, billions and billions of stars.
It makes you wonder.
It does. If Earth is the only place with life because of this specific fragile balance, how careful should we be with it? How precious is this geoid?
Extremely. It's the only home we have.
And on the flip side, considering the vastness we discussed, billions of systems, billions of planets likely orbiting those stars, is it arrogant to think we are alone? Is the address of humanity the only address in the cosmic phone book?
That is the ultimate question. It's known as the Fermi paradox. If the universe is so big and so old, where is everybody? The age of humanity is known, but are there other addresses out there waiting to be discovered?
Something to mull over tonight when you look for the Saptarishi in the sky.
Indeed. Look for the pointer stars, find the North Star, and wonder who else might be looking up at their own stars, asking the same questions.
All right, friends, that brings us to the end of this deep dive.
We hope you enjoyed decoding the cosmos with us. It was a pleasure to revisit the neighborhood.
A final reminder. If you found value in this deep dive, please subscribe to Simplified UPSC by PPP on YouTube. It helps us immensely and ensures we can keep producing this content for you.
And check the Telegram channel for the free notes and PYQs related to this chapter. Don't let this knowledge evaporate. You have to practice it. Apply the logic we discussed.
For the serious aspirants, and you know who you are, the private Telegram library is waiting. It has premium notes, detailed explanations, and model mains answers. It really is the upgrade your preparation needs. Just DM on the public channel to join.
And don't forget to like, comment, and share. Let's keep learning together.
Until next time, keep looking up.